Hi, let us continue with the new method dropping entries from an axis. Important essential functionality of Pandas. Here, the drop method will return a new object with the indicated value or values deleted from an axis. Let us look at the docstring of the drop method. If you look at the docstring signature, it accepts labels axis is equal to 0 by default, that is along the row axis or row index. Index is equal to none by default and columns is equal to none by default and other optional arguments. So in place is equal to false here. This is very important parameter. We will see later while working through it. And the docstring says that it returns a series with the specified index labels removed. Let us keep this information in a separate window. Now let us see the docstring of drop method and data frame object. The signature remains same, but docstring says it drops specified labels from rows and columns. It drops the labels by default along the row index, that is axis is equal to 0. We can replace it by columns to drop the labels across columns. We can replace axis is equal to 1 or columns to replace or to drop the labels across the columns. Let us keep this window in a separate. Let us keep this information in a separate window. Let us create a simple series with a range of values from 0 to 6 using np.arrange6 and with the index a, b, c, d, e, f. Let us delete or drop a row index label A from the data created. We got the dropped series. The index label A has been removed and its corresponding value also. We can assign it to a different name to create a new dropped object for the specific purpose. So here I am creating a new different object n_data by dropping the row index label A. To delete a multiple row index labels at a same time or simultaneously, we can pass a list of row labels. Here I am removing labels A and D, say for example, by passing them as a list of labels. Now, with respect to the data frame object, the index values can be deleted from either axis. So, I am creating a simple data frame object with the name data frame with the range of numbers from 0 to 15, reshaped into 4 rows and 4 columns as a two-dimensional array with row index labels A, B, D, E and columns with some state names. Let us remove a sequence of labels by passing them as a list, say for example A and E. Notice that we didn't specify the axis to remove the index labels. This is because by default the drop method removes the labels along the row index, that is axis is equal to 0. So hence here no need to mention axis is equal to 0. That means we no need to specify it explicitly. But to remove the column labels, say for example Kerala, along the column axis, we need to pass axis is equal to 1 or axis is equal to column. To delete a multiple column labels, we need to pass them as a list of names. Say for example a list of Kerala and Andhra along the column axis. We can also use axis is equal to columns instead of axis is equal to 1 to make sure that we are performing across the columns only. We will get the original data back even after performing an operation like drop several times. This is because we have in place is equal to false in the signature of the drop method by default. So we got the original data frame. This is because the signature in place is equal to false. So here we have in place is equal to false. We can use in place is equal to true to avoid returning a new object. Let us use in place is equal to true to remove the column labels, say for example Kerala, Andhra along the column axis. Now if I try to access the original data frame, I won't be, because I have passed in place is equal to true, hence I will get only the modified object as the new object. Again, if I call the data frame back again, I will be getting the same data frame that is dropped. So we should be very careful while using in place is equal to true. It is very harmful as it destroys the original data or destroys any data that is dropped. Therefore, unless you trust, don't use in place is equal to true. Instead, you take out the dropped object as a new object as I mentioned earlier.